Hello, welcome to this lecture. So in this lecture, we will design the doubly reinforced beam. So in this lecture, we are going to discuss about the steps that are being used to design doubly reinforced beam, and then we will solve an example to understand how we design this beam. So in the previous lecture, I have discussed about the analysis of doubly reinforced beam, how do we analyze it, and we have solved an example. Now, in this lecture, we are going to design it. So, talking about the doubly reinforced beam design, first we will understand what is doubly reinforced beam, although I have discussed this in the previous lecture, but for a recapitulation, we will understand this. So basically, we use doubly reinforced beam when the depth is restricted and the applied moment due to the external load is greater than the strength of the balanced singly reinforced beam. So in that case, what we do is we use doubly reinforced beam. We design the beam as doubly reinforced beam. And diagrammatically, if we look at it, then here you can see this is the case of singly reinforced beam in which we provide reinforcement in the tension side, and on the compression side the compressive stresses, compressive load is borne by the concrete. But in case of doubly reinforced beam, the tension is borne by the steel again, but the compression is borne by the steel and the concrete. So this we can assume as a auxiliary or imaginary section which is comprising the compressive reinforcement, and to balance it we provide extra tension reinforcement. So this imaginary section, when we add this section to this one, then we get this section which we call doubly reinforced beam. So the use of doubly reinforced beam is very beneficial in many aspects. Well, such as uh, the important advantage is it reduces the long-term deflection, which which is resulted from the shrinkage and creep. So I have already discussed about the shrinkage and creep, which generally occurs in the concrete. So because of this creep phenomena and shrinkage, the durability of the concrete is also affected, and because of that the deflection may increase. So in the long term, if we use doubly reinforced beam, then the deflection can be uh, decreased. It reduces the deflection when we provide the compressive reinforcement. And also these doubly reinforced beam, they are useful in the zone called the seismic zone. So in the area where which are prone to the seismic or earthquake forces, in that area also we can provide doubly reinforced beam because they can withstand the reversal of the load. Well, what is reversal of the load? When basically, if I take an example, say this is a beam, and this beam, say it is designed for this type of load, which is the vertical load. So this vertical load will try to will try to bend this beam in this manner. But what if the force is going, by chance if the force is getting like in this direction for the same beam, in that case the beam may deflect in this manner. So in that case, the reinforcement will be required on the upper side. So in the case of doubly reinforced beam, we are providing reinforcement on the upper side and on the lower side also. So by chance, if there is a reversal of the load, then still we will be having reinforcement which we have provided as a compressive reinforcement, but they may take tension for load also in case of the reversal of load. So this reversal of load may occur due to the effect of wind, due to the effect of earthquake. So in that scenario, provision of the doubly reinforced beam will be very advantageous. So we will continue our this discussion in the next part. Thank you.